Hello and welcome to this new video in our series, A Beginner's Guide to the C Programming Language. In the last video, we covered the basic data types of C and how to declare and use variables and constants. We also had practical demonstrations of creating solutions and projects in the integrated development environment. We edited our code, created executables, and used the debugger. In this video, we will cover the operators in C. Operators are symbols that are used to perform operations on data in a computer program. Every language has its own set of operators and defines the result of these operations. Now, a program in C consists of program statements. There are different kinds of statements. Declarative statements that are used to declare variables, expressions that are used to perform operations and function calls, and flow control statements that change the program's execution flow, like in branches and loops. In our last video, we explained how variables are declared using declarative statements. In this video, we will work with expressions. Now, an expression is a collection of operations. This expression contains three operations: multiplication, addition, and assignment. Each operation has operands, which are the data that the operator operates on. There are many kinds of operators, and they are classified in two ways. You can classify operators based on its function or on the number of operands it uses. Functionally, operators are of these six types. Arithmetic operators that are used to perform arithmetic operations. Relational operators that compare their operands and return a true or false value. Logical operators that combine multiple relational operators in an expression and are used in conditional expressions. Bitwise operators that perform operations like setting, resetting, and inverting individual bits of a binary value. Assignment operators that assign results of an expression on the right-hand side to an L value on the left-hand side. Note that L value is a named variable because you cannot have a constant value on the left-hand side of an assignment operator. As you can see, the assignment operator is combined with multiple arithmetic and bitwise operators to provide efficient operations. Finally, we will cover some miscellaneous operators like size of, address of, the ternary operator, and the typecast operator. Another classification of operators is based on the number of operands it has. They are unary operators that operate on a single operand, binary operators that need two operands, and ternary operators that have three operands. Now let's look at each of these different types of operators. Arithmetic operators perform arithmetic operations. The plus, minus, multiply, and divide operator perform the sum, difference, product, and division operations and return a result. They are binary operators and can be performed on any numeric variable. Examples of arithmetic operations are shown here. The mod operator returns the remainder after integer division. It is a binary operator but works only with integer type operands like char, short, long, and ints. This is because an integer division has an integer quotient and a remainder, whereas a real division will always return a fractional quotient and does not have a remainder. The next set of arithmetic operations are the increment and decrement operators. These are unary operators and need only a single operand. The increment operator increments the value of the operand. The decrement operator decrements the value of the operand. These two operators have two versions, the pre and post version. In an expression, post-increment operations are performed after the expression is evaluated, whereas pre-increment operations are performed before other operations. This is shown in lines 2, 3, and lines 4 and 5. Now, whenever you write an expression statement, you need to keep in mind two important things. The first is the precedence of operations within the expression, and the second is the conversion of types that will take place implicitly or are needed explicitly. Let's look at precedence. As we have seen in the example of arithmetic operations, every operator has a precedence value in an expression. The precedence is the order in which it will be performed in an expression. The table shows the precedence of operators in an expression. Now, when two operators have the same precedence, they are evaluated from left to right. As can be seen in the example here, in the first statement, the multiplication is performed first, followed by the addition, and then the assignment. In the second statement, addition is performed first, followed by multiplication, and then the assignment. The precedence of operations can change the result of an expression. So be aware of the precedence of operators in an expression. The second thing that you need to be aware of is type conversions that take place in an expression whenever there are two operands which are of two different types. There are two kinds of type conversion, implicit and explicit. The compiler enforces implicit type conversion rules in an expression where the two operands are not of the same data type. These rules state that all chars are converted to ints and all floats are converted to double. In other operand types, the type conversion ensures that the data type that has a lower range and precision is converted to the data type with a higher range and precision. For example, if one operand is an int and the other is a float, then the compiler first converts the value of the float to a double and then converts the int to a double value. The operation takes place as a double operation, returning a double result. Note that type conversions only apply to the value of the variable and the type of the variable does not change permanently. Now, these implicit rules do not apply to the assignment operator. Depending on the type of the L value, the right-hand side of the expression may be promoted or demoted to the type of the L value as needed. Unlike implicit conversions enforced by the compiler, explicit type conversion occurs when the programmer wants to change the type of the value of an operand. This is done using the typecast operator. This is a unary operator where you specify the type name in parentheses to the left of the operand. The cast operator converts the value of the operand to the type specified. Here are some examples of implicit and explicit type conversions. In the example shown, the third line performs an operation with operands of different types. Here the value of b is promoted to a double, so is the value of the int a. The multiplication results in the double value 276, which is then demoted and stored in the integer L value C. In the following operation, the float variable b is demoted to an int value, so it loses its fractional part. This is multiplied by the integer, which results in an int value 275, which is stored in the variable c. As you can see in both cases, variable c has a different value because of the different types of conversion that happen in the expression. The first conversion is implicit, the second is explicit. Now let's discuss bitwise operators. Bitwise operators are used to perform operations on individual bits of an integer type binary value. These operations are setting a bit, resetting, and inverting a bit in a binary value. As mentioned, these operators only work on integer type operands. The first four bitwise operators are AND, OR, XOR, and NOT. The bitwise AND operator ANDs each bit at the same bit position and will set the resultant bit to 1 if both the bits are 1. You can use the AND operator for two kinds of operation. Firstly, it is used to check if a bit is 1 in any bit position. For example, if you want to test the value of bit 5 in an integer value, then bitwise AND it with a masked value having 1 in the bit 5 position. As shown here, if the resultant value is not 0, then the bit is 1, else it is 0. Besides checking a bit value at a position, you can use the bitwise AND operator to set a bit value at a bit position to 0. For example, to set a bit at a bit 5 position to 0, bitwise AND it with a value having a 1 in all bit positions except for the bit 5. The operation will result in bit 5 being set to 0, with all remaining bits remaining the same. The bitwise OR operator ORs each bit at the same bit position. The result will be set to 1 if either 1 or both bits are 1. This operator is used to set a bit at a bit position to 1. The example shown here sets the bit 6 of the original value to 1, the value of all other bits remaining the same. Then you have the bitwise XOR operator. The XOR operator is an exclusive OR operator. It results in a 1 only if one of the bits in the same bit position is 1. If both the bits are 0 or both the bits are 1, the result is a 0 in that bit position. The bitwise XOR operator is used to invert a particular bit in a bit position. You can do this by XORing it with a value of 1 in that bit position. In the example shown here, we wish to invert the bit position 5 and 6. So we XOR it with the value having ones in that bit position. After XOR, the bits in the original value will get inverted in those bit positions, the remaining bits remaining the same. So the AND, OR, and XOR bitwise operators are binary operators requiring two operands. As demonstrated here, they can be used to set, reset, invert, or test a bit value in an integer variable. The bitwise NOT operator is a unary operator. It has only one operand and is used to invert each of the bits in the value. That is, it is used to create the ones complement of a number. Finally, the remaining two bitwise operators are the left shift and the right shift operators. The left shift operator shifts the bits to the left by a number of positions specified, padding it with zeros on the right. Similarly, the right shift operator shifts the bits to the right, padding zeros to the left. The examples here show the left shift and the right shift operators in action. The next type of operators are relational operators. Relational operators compare the two operands, and depending on the values, it returns a logical or a Boolean value of true or false. In C, the Boolean value false is 0, and any other non-zero value is treated as true. Relational operands are greater than, less than, greater than or equal to, less than or equal to, equal to, and not equal to. The example shown here shows the result of each of the relational operations. Note that the result of each operation is an integer value of 1 or 0. Also note the relational equality operator with two equal to signs. This is unlike the assignment operator, which has a single equal to sign. New programmers often mix up the two. The last example shown here would throw a compiler error because the left-hand side operand is not a variable. Let's now look at logical operators. Logical operators are used to combine multiple relational operations in an expression. The operands of a logical operator have a logical value true or false, and its result is also a logical value. Two logical operators, AND and OR, are binary operators. The AND operator will return true if both the operands are true. The OR operators will return true if one or both the operands are true. The logical NOT operator is a unary operator that takes only one operand and inverts its logical value. The examples shown here demonstrate logical operators. Each of these expressions shown here will return a true or false value or a 1 or a 0. The result is explained for each one of them. Then we have the assignment operators. In its simplest form, the assignment operator will assign the value of the right-hand side expression to the left-hand side variable. The assignment operator has the least precedence in an expression. Other forms of the assignment operator combine arithmetic and bitwise operations. These are binary operators that perform arithmetic and bitwise operations on the left-hand side variable. The result is stored in the left-hand side operand. These are more efficient operations and must be preferred instead of the long-form version. For example, instead of the statement A is equal to A plus B, you should use A plus equal to B. Finally, we will discuss a few miscellaneous operators. The size of operator returns the number of bytes that are allocated to a data type. It is a unary operator in which the data type is specified in parentheses to the right of the size of operator. Size of float returns 4, size of double will return 8. The next miscellaneous operator is the address of operator, which is also a unary operator. We know that every variable has two components, its address and value. Generally, we use the value of a variable in expressions. However, there are multiple situations where we would need to know its address. One example is when we wish to change the variable's value indirectly using its address instead of accessing directly with its variable name. We will show you how this is done in our discussion on pointers in a later video. The address of operator will return the address of the variable. The ternary operator is an operator in C that takes three operands. It is used in place of a simple if-else branch statement. As we will see later, it is used to define macros using compiler directives. The ternary operator has three operands. The first operand is a conditional expression that evaluates to true or false. Following the conditional expression, the second and third operands are expressions that would return some known value. The colon character separates these two expressions. Now the ternary operator works as follows. The conditional expression is first evaluated. If it evaluates to true, then the second operand is executed. If it evaluates to false, then the third operand is executed. As shown here, if A is greater than B, then A is returned. Otherwise, the value of B is returned. So essentially, this ternary operator returns the maximum of A or B. Finally, the last miscellaneous operator in our discussion today is the typecast operator. We have seen an example of the typecast operator earlier. The typecast operator is used to explicitly convert the type of an operand to the specified type. So we have reached the end of our discussion on operators in C. We have a few more operators to be discussed, which we will do when relevant. Let us now look at how these operators work in practice. We will create a solution and project as shown before. Add a new source file to the project and code the program. Here is the code after it is entered completely. Note that we are performing some of the operators discussed in this video. We will single step through each of these operations, showing you how they are executed. In the first example, we demonstrate simple arithmetic operations and the precedence of operations. Here we have initialized the two variables num1 and num2. In the first operation, the result contains the value of the add operation, that is 8. In the second operation, the multiply operator has higher precedence, so the value in the result is 20. In the third operation, we change the precedence of operators in the expression using parentheses. The result of the operation is now 40. The next operation performs an integer division to give you a quotient of 1. Finally, we perform the remainder using the mod operator, and the remainder here is 2. We now look at the second example to demonstrate the impact of implicit type conversions. We perform a simple Fahrenheit to Celsius conversion. In the first operation, the result is 0 because the division 5 by 9 is an integer division resulting in the value 0. The final value is also 0. In the next operation, the result is 37. Here we have implemented explicit conversion, which converts the value of the constant 5 to double. This results in a floating point division to give us the correct value. We change the order in the following operation. Since the multiply and divide have the same precedence, they are evaluated from left to right. The result is value of 37. The next operation is similar to the first operation, only that the constant division is now a real division. The result of the right-hand side operation is a double value. This double value is demoted to an integer and stored in the variable. In the following operation, the result variable is a real data type, and the operation now stores the data as a double value of 37.777, which is more precise than an int value. Finally, we will have a look at relational and logical operators. In the first operation, both the relational operators return true. Hence, the AND operator also returns true. In the second operation, the first relational operation is false. Hence, the AND operation also returns false. We then change the value of num2 to 5 so that it is equal to the variable num1. The results in the next two expressions return true or the value 1. Finally, the logical NOT operator returns false because the relational operation num3 less than num4 returns true and the complement of true is false. This brings us to the end of our demonstration of operators in C. We covered different types of operators in C and understood some of the finer points in how they work. Please like and share this video and follow our channel for more. In our next session, we will have a look at the structure of a C program and different kinds of C functions. Thank you for joining us. See you again in our next video.